They fly over here and with the jet stream.
Pinpoint asteroids in orbit, then hurl y'all thousands of miles an hour towards it.
It seems Witsit is still confused about what flat Earth map he wants to use. 1 minute he says it's a straw man. Next he's using Flat Earth Banjo's version to explain flights and jet streams. I really didn't want to make another video about this, but since you so arrogantly claimed victory on this subject and used Flat Earth Banjo's video in a live stream, which I debunked almost a year ago, let's revisit this and display just how astronomically wrong you are. Again. First of all, let me demonstrate exactly how much quote-unquote research you actually did. This particular flight that you're going over is actually QFA-14, a one-way flight from Aziza, Argentina to Darwin, Australia, which happened on October 5th, 2021. The flight duration was 17 hours and 41 minutes.
So when they fly this way, it takes 11 hours. When they fly this way, it takes 14 hours.
Where exactly did you get 11 hours from?
I looked it up.
Oh, right. You looked it up. Got it. Or maybe you're confused with another non-stop flight on the other side of Flat Earth that takes 11 hours with the jet stream. Either way, both of them will be impossible on Flat Earth's map you're displaying here. We'll go over that in a minute.
Just don't always do that. And then they, so you have one thing here where the planes can go faster than they claim that they do. Now, that's one aspect of it. You don't even have to go there, though. You don't have to invoke this, oh, well, maybe they do what we don't know. They go fly on the south where the jet streams are faster.
Again, Witsit, please provide a citation that states jet streams are faster in the south specifically. Until you do that, you're just talking out of your ass.
I looked it up. That I really wanted to cover because I'm so tired of hearing people pretend this is some home run from the globe. It's so stupid. So planes actually go much faster. There are planes that go way faster than what people think they do. You got planes going 750 miles per hour. Yes, huge planes.
Listen, man, you really should research more instead of just reading off of your script. Had you actually looked up the maximum speed for a 787-9 Dreamliner, which is the aircraft that flies these routes, you might have learned that its maximum airspeed is 593 miles per hour, and the cruising speed is about 567 miles per hour. Also, another little cool fact is that the maximum range is 7,636 miles. That number is going to be real important here in a minute, so stay tuned.
Obviously, because when you go look at 24/7 flight radar and you go look at all the stuff that the Globers want to bring up, they're always reporting 500 mile per hour, 550 mile per hour speeds there and back. But there's a 3-hour difference. How does that work? Because it's not reporting ground speed, as in how much ground is covered by the plane. It's reporting the airspeed. Okay, I looked it up.
No. Again, Witsit, this is what happens when you make claims and don't research. Had you actually gone to Flight Radar 24 and looked up these two flights, you would have learned that the ground speed that you claim they don't account for, which is right here, is not 550 miles per hour every single flight in both directions. And the speed is clearly lower on average during the return flight. So, thanks for playing, bro. Now, this is the part of the video where I break down the speed, distance, and time with simple 3rd grade math that absolutely annihilates your claim about this flight path that you decided to foolishly borrow from Flat Earth Banjo. And since I already broke it down in a video I made about a year ago, this shouldn't be too hard. Now, pause the video, go grab a piece of paper and a pencil, and I'll even let you use a calculator to make it even easier for you to follow along. Now, this is your AKA straw man map that you decided to use for whatever reason. I guess because Flat Earth Banjo is your boy and you have no other source you can go to. Here's my first question, Witsit. What airline would travel all the way out here and take a ridiculously longer route to get to their destination, instead of flying in a straight line, which would maximize fuel economy and save the airline possibly millions of dollars a year? You really didn't think this over, did you?
I looked it up.
Anyway, let's move on. Since you chose this route, we have to figure out the actual distance around this portion of the circle. Distances on an AE map are measured from the center outward. With that information, we can get the radius, diameter, and the circumference. Darwin, Australia is 7,068 miles from the North Pole, And Buenos Aires in Argentina is about 8,622 miles from the North Pole. The difference in latitude of those locations is about 1,554 miles. We want to choose a spot right in the middle of these two latitudes, which just so happens to be 777 miles. So we take 8,622 miles minus 777 miles, and we get 7,845 miles. That'll be the radius of our circle. Times that by 2, and we get 15,690, which is the diameter of our circle. So when we take the radius and we solve for the circumference using 2 times pi times the radius, we get 49,292 miles, which is the circumference distance of this latitude. Are you still with me, Witsit? Pay attention because we're not done yet. Now, just like I did in the previous video, we have to figure out the distance between each latitude line, and we do that by dividing the circumference we just figured out by the amount of longitude lines on Witsit's map. So we take our circumference, 49,292 miles, divided by 24, and we get 2,054 miles, which would be the distance between each longitude line around the outside of our circle. Now, we just multiply 2,054 by the amount of longitude lines between our two locations, which is 11. That comes out to 22,594 miles. So that means Witsit's little 787 traveled a whopping 22,594 miles. Now, remember in the beginning when I said a certain number will be real important? That number is 7,636. That's the maximum range of a 787-9 Dreamliner. I really hope those jet streams will help it glide the other 15,000 miles it needs to travel. Yeah, good luck with that, Witsit. Now let's get to your jet streams, and this is the fun part. Let's go ahead and assume that Witsit's jet streams are blowing at the maximum 275 miles per hour every single day. Then let's assume that the aircraft is traveling at its max airspeed, which is 593 miles per hour. That gives us a ground speed of 868 miles per hour. Since the distance we figure out on Witsit's map was about 22,594 miles, that means an aircraft traveling at 868 miles per hour, ground speed, would take about 26 hours. Looks like your jet streams are going to have to be a little bit faster, Witsit. You know what? Let's bump that jet stream up to about 2,200 miles per hour. There you go. Now you can get there in about 10.5 hours.
I looked it up. I
just got 4 words for you, Witsit. Thanks for playing, bro. Once again, thanks for watching. Don't forget to like, share, and subscribe if you like this video. And check out the rest of my videos if you're interested. And as always, peace.
Pinpoint asteroids in orbit, then hurl y'all thousands of miles an hour towards it.